Okay, from what we learned earlier this evening, we realized that the function of the volume in terms of the breadth and height was v equals to bh times the square root of 4 minus b squared minus a squared. So if we like to work in matlab, we will actually assume the symbolic environment. So here our volume is a function of the b and h. So we will start by symbolizing our b and h, sims bh. Now our function volume was b times h times the square root of 4 minus b squared minus h squared, right? H squared. So we have something like this. And now our goal is to find for the maximum volume with the breadth, height, and length, right? So let's find for the first derivative of the volume with respect to our b and h. So in doing that, we have the v, the h, which is so the diff of the volume with respect to h. And if you find for the v, the b, we have the diff of the volume with respect to the b. That gives us this. Okay, so to find for the value of the h and the b at the maximum volume, we find for the value of the b and h by setting our equations to 0, right? And then summing them simultaneously. So to do that, let's assume two variables here. So our b value, say b var, and our h value, let's say h var. So having this, we solve by using the matlab inbuilt command solve. So our first equation, any of them will do. So the v, the h, and we have the v, the b, right? And since we have b var coming before h var, so we solve b first and h first. So we have these values of b and h. So the b var, we have 0 minus 2, 2 minus in that order. And the h var too, we have in that order, right? By looking at it, we have plenty zeros and plenty negative values for the b and h, right? But since b and h are length, it can't be 0 and it can't be negative. So we have this and that is 2 and 2 over root 3. Yeah, so we have this and this for the value of the b. In the same way, we have this and this. So you see that these two are also the same, these two are the same. So if we say our b var is now, let's say that's the b var, it's now I'm just declare set. So our 2 is the third entry of b var. So 2 and our 2 over root of 3, that is this expression is 1, 2, 3, 4, 5, 6, 7 is the 7th entry. So it's number 7. So we have this 2 and this, and our h v, that is the value of the height. So let us fetch those values from there. So h var, we are taking which element? 1, 2, 3, 4, 5. So the 5th element, and so 5, 6, 7, 8, the 8th or 9th element. So we have this now. So now we have 2 and this, and 2 and this. Okay, so now we have 2 values for the b and 2 values for the h. This and then this and that. So look for the right combination to give us the maximum volume of the box that can fit in a sphere, right? So we have HV and BV, right? Let us put them on the side. Now to check to see which will be the maximum and the minimum, let us find our Hessian matrix of the equation. So we have matlab inbuilt function Hessian, and we are going to find for the volume expression. So it has 2 variables b and h in there. So we just find for the Hessian. You see we have a long matrix with 4 entries. This is the first. We have the other half on this side and the last one on this side, right? So if I'm to pick our first one, so let's say the hairs, I'm just picking the first entry of the hairs. And if I want it to look a little nice, I use the inbuilt preservation. So this becomes our first entry for the Hessian of the volume expression, right? So now since we had two values of the b and two of the h, right? So we look for the best combination to give us the maximum volume. So in doing that, let's say I have this variable a1, and in this variable I'm going to substitute my first two combination of the b and h into our Hessian matrix, that is the Hess. So I use the subs, and I want to put it in this function, the Hess, and I want to put in place of b and h, right? So here what I want to put for the b is that the first value for the bv, and then what I want to put for the h is the first value of the hv. So I'm just taking the 2 So for our bv, its first is 2. Now hv, its first is 2, right? So for our first combination, we have 2 for the b and 2 for the h. So our goal here is to check if the value of the Hessian is going to be negative, and we see that okay, this is maximum. So let us try it out. So we have it to be something like this. So we have 4i, 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 meaning that all of the entries in there are complex. This is not what we actually want. So now next combination, let's say a2. A2, we have the subs. So we have our s. We want to put in place b and h, and we are substituting, let's say, our first b. So b being first, our first b, and our second b. Right. Yeah. So we have this one too. We have complex in there, and this defeats the whole purpose. Now let us go to our last combination. So our second. So we have b and h. So we have the second of bv, and then the second of hv, and that is the 2 times 3 power 1 over 2 over 3. So we have this expression over here. So if I like to convert this expression to double precision numbers, I say double of my a3, just to change it to a numerical value, and we have something over here. So if I find the argin of our a3, we have this. So I'm just double my answer once again. I don't know why. So we have minus 6.92H2 and minus 2.3094. So these two negative values mean that the points, this point give the maximum roots or the maximum volume of the box that is to be inscribed in the sphere. Yeah.